There we go.
Okay, what we're displaying here is the optically enhanced weapon orientation module from Inertial Labs that is referred to as OptoWOM. On top of the theodolite, we have the WOM device here and a camera mounted in line with the WOM device. The camera is looking out into the horizon and picks out features in the horizon that it uses to track changes in heading as we rotate the device on the weapon, or in this case on the theodolite. On the screen, you're seeing that it's tracking the heading for the OptoWOM and our traditional WOM without any optical reference, the magnetic heading, and the optical system as a standalone. We're going to show during each what we call firing events, we'll make a large screen that will show us the answer from the system. So we'll do a fire event right now that will show what the system is reading at this moment. So go ahead and do that. So this is simulating doing a fire event on the weapon. He selects fire, it shoots, and on the screen it's showing us what the WOM is measuring versus what the actuals were for the target. So the actual target is at 230 degrees in heading and 0.5 degrees pitch, and the WOM is reading 230.02 degrees and 0.49 degrees in pitch. Now, at this point in time, the system has no magnetic interference and no optical interference, so it's the ideal situation of it operating. I'm going to move the theodolite 5 degrees and show another firing event. Close that.
Frank called I'm going backwards.
So on the theodolite, I've now moved exactly 5 degrees. You can see on the screen it does show that the WOM has actually changed. Right now the OptoWOM is reading 235.1 degrees. The WOM by itself is 234.8. Both are good, within plus minus 0.2 degrees. Now we'll do a firing event.
I wanted to. You want to go to 322.9?
Oh, here it says it's 322.9.
He puts in the offset, so we move 5 degrees.
You're right. So I made you go.
It's showing the picture that we're using. And now it's saying that the measured is 235.13 degrees and 0.47 pitch, where the actual is 235 and 0.5 pitch. So we're within 0.03 degrees in pitch and within 0.13 degrees in heading. Now I'm going to go to a little bit further away, 15 degrees.
Come up there, the right angle. What? Yeah, mine reads 307 degrees, but it's 130.
So now I've moved on the theodolite 15 degrees. On the screen, we see that everything is still tracking, so the optical system is doing well, the WOM is doing well, the magnetic system is doing well. We'll do another fire event.
I'm pretty sure that's not in the operator manual.
You're supposed to check to see if it's
15.
It is. Yeah.
It's a lighter.
It's in the heading offset of 15 degrees.
Can't see.
Okay. Now, measured is 245.4 degrees, pitch is dead on, and target is 245 degrees. So we're still within 0.4 degrees of the actual. So now I'm going to move back to the 0 position, and we're going to apply magnetic interference and do the same thing.
What happened? I've got ground. I'm not sure if we haven't reached that line of pitch. I don't know if we did it on the wiring. He's probably within a couple of degrees. Brandon's got the FO. All right. Brandon.
Okay, now I'm back at the 0 position. We still show that all things are tracking very well. We'll go do a fire event.
I'm going to go back.
They were talking about this yesterday. I think that's a little higher.
0. Yeah.
I used to be able to look down.
Okay, it shows us the image that it sees, and we got 229.99, so we're within 0.01 degrees of actual. So everything tracked well. That was expected. Now the WOM system utilizes magnetometers, which have the ability to be affected by magnets and magnetic field interference. So I'm going to apply magnets to it to where the magnetic heading is no longer usable, and we'll show that it still tracks with optical.
I'm standing out here now. I've been out here for 2 hours. My back. I know how much metal magnets put up there.
These are permanent magnets. They're
you working on
the total magnetic field is probably around 70,000 right now. Well, it means it's analogous to strapping on the mortar. So it's about the same. Also, you can look right now. If you look at the headings, we have 230 degrees is what the WOM is reading. Our magnetic heading is 283 degrees. So if we were relying on magnetic sensors only for our heading reference, we would be off by 50 degrees. Okay. Optical system, of course, stays at 230 because we haven't moved. So now we're going to acquire, we'll do a fire event at this point to show that we're still at our zero.
Okay, so now, but I don't want to hold it up so that it goes to 320 degrees, which is something in a positive direction.
Okay, so the measured is 229.97, the actual is 230, so we're within 0.03 degrees of actual, and 0.49 pitch, 0.5 pitch. WOM by itself also is able, when staying on a single target, to deal with any type of magnetic interference, but as you acquire new targets, the WOM data will start to be off a little bit, where the optical system will remain accurate. So I'm going to move to the first target.
Whatever you want up there.
So I've moved exactly 5 degrees on the theodolite. Looking on the screen, the WOM heading is at 235.1 within 0.1 degrees. WOM by itself is 235.8, so it's off by 0.8 degrees. Magnetic heading is still off by 50 some degrees, and the optical heading is really what we're using for tracking, so it matches the WOM. So we do a fire event.
Whichever way you calibrate this thing,
So now it says the measured is 235.1, even though our magnetic heading says it's 280 something. Pitch is still dead on, and the target was 235. So now I'm going to go to the target at 15 degrees off, which is more analogous to the edge of a zone, and we'll see how the optical system tracks.
The difficult way.
Yeah, it would have to be. Well, I know that was a sticky issue.
yeah, because it's white there. Okay, ready?
Okay, now I'm at 15 degrees. So looking on the screen, we've got 245.3, which is within 0.3 degrees. 246 from the WOM. The WOM is off by about 1 degree by itself, and optical is still tracking. So we do a fire event. So what's happening as we go from target to target, the WOM by itself relies on gyroscopes to understand how far we've moved. Gyroscopes have a cumulative error in those situations, and that's the reason why the WOM error is growing per target. So the actual that we're getting from the system is 245.4, still more than a 2 times margin for the error that we're allowed. 0.5 degree pitch, and the actual is 245. So now I'm going to go to 20 degrees, which is actual edge of a normal firing zone is plus 22.5 degrees. So I'm going to go to the edge of a firing zone.
Easy equation. Do it.
Did you align that pitch? I didn't align the pitch, but I still can.
And a representative that we have is let me help us.
Yeah. And what should it be?
Now I'm at 20 degrees. Reading 250 for this, 250.6, 0.5, so about 0.5, 0.6 off. WOM is off by 1.2 degrees. Magnetic heading is still, of course, out of whack. Go ahead and fire.
That's like, okay,
I just wondered what to do it. No, I agree. I just don't
Write that down.
Okay, so measured is 250.53, actual is 250. So again, we still have a 2 times margin based on the fact that we have the optical reference. And that's really it. No calibration is needed with the optical system. The system actually has an ability to use the data that it's measuring to develop a calibration profile. So when soldiers are using this in the field, they would never have to go through any of the calibration processes that they have to today for the WOM. In addition to that, what we really showed here was when that magnetic interference is introduced, be it a tank, a weapon, or whatever, the system remains accurate indefinitely.